In this, we are going to study some of the questions that can appear in a second exam of a pre-calculus course. The topics will be ranging from average rate of a function and some transformations, solving quadratic equations using completing square, the formula, factoring method, and those three major methods. And then we can talk about how to solve certain inequalities and find standard form of a quadratic function and how to use a quadratic function to find a maxima and minima. And those are the kind of topics we can discuss in normally test 2 of a pre-calculus course. So let's go over one by one. So as the first example, we can look at the average rate of a function. So what's average rate of a function? So if you remember the theory, you may remember that so you have a function. So let's say this is your function. So what we're trying to do, so you have two values, a and b, a and b. So what we're trying to do, we try to find the function value at a, so which is we call fa, and the function value at b, so which we can call fb. And then we know the average rate of the function. So what we're trying to do, we try to look at the change in the y direction, that means the difference between fa and fb, so which we normally call delta y, and divided by the delta x. So this is what we normally write as the um, average rate of change. So in this case, so we can write the average rate of change. So average rate of change. So which is by the definition, we call FB minus FA divided by B minus A. The order matters. So if you write FB minus FA, you have a B minus A. But if you write FA minus FB, then we write A minus B. But normally we write FB minus FA because like A is the starting value, B is the ending value. So we subtract the beginning values, the initial values from the ending values. So that's how we normally write it. Um, so that's the definition for in this case. So I'm gonna highlight that. So that's the formula for the average rate of change. Now what we're gonna do, since you know the function, we're gonna plug in the values there. So in this case, what we have, and you can see that, so you can identify A and B. So we're gonna say this is the starting value. So in this case, -1 is the A, and 7 is the B. So that means what happened here is this gonna be F7 minus f minus 1 and divided by 7, and then I'm going to put a parenthesis here just to avoid confusion. So that is what we are trying to find. So we're just going to plug in the values there now. Since you know the two functions, we just need to plug in the values. So we're going to plug in 7 wherever you see x, so that means 7 cube minus 2 times 7 plus 1, that's the first one, and we can put a parenthesis around and minus the second one, so which is -1. So you have to be careful. So this is -1 cube, and then minus 2 times -1, and then plus 1 divided by, so you can see 7 negative negative become +1. So that's what you get. And then if you simplify, so I'm going to write a few more terms. So you're going to see that 7 cube, which is 343, minus 14 plus 1. That's what you get from the first one. And from the second one is a -1 cube. That means you multiply -1 3 times by itself, which is -1. And then negative negative become positive, you get 2, and then plus 1. So that's what you get from the second one. And then bottom become 8. So if you write a few more, you get 330, and then the next one becomes, because you see this get cancelled. So it is -2 divided by 8. Once you simplify, you should get 41. So that is the average rate of change of this function. Yeah, so we use the definition and plug in the values. So average rate of change is we written as delta y over delta x. Okay, so let's go to the next problem. So in the next problem, what we're trying to do, it says that use the transformation. Um, so we talk about transformations method in another video, and you can find the link in the description. So this is just for such examples. Um, and then also in their question, they are also asking find the domain and the range. So that we can do after we graph the function. It might be easier that way. So let's go one by one. So let's start. So when you do the transformations, so you have to be careful. What we're gonna do, we're gonna start with one of the library functions, or what we call the basic functions or the parent function, and then we're gonna grow it step by step. So we always start with the library functions, and we try to introduce transformation one by one. Um, Good. So, so if you look at the first problem, which says that, so which is fx equal negative 2 x plus 3 squared plus 4. And then also, if you want, you can write this one as negative 2 x minus minus. When you see a plus sign, we normally add two minus signs, and then squared plus 4. Now what we can do, we can see what is the major function, starting function we have here. So you can see that the major function would be x squared. So how to do that? Just remove all those constant terms, like like we can remove all of these terms and to get the basic function. Once you remove them, you can see it's just x squared. So we have x here, and we have x squared there. So that means x squared is the major function. So that's where we can start with. So it is y equal x squared. And then, so I'm going to write the functions first, and then we can find the final graph later. So that's the first one. So what's the next one? And you can see there's a horizontal shift. So since it is a negative number, so it's going to move this direction. So it's because negative 3. So it's not going right, it's going to go to the left. So it's a negative 3 means it's going to go to the left by 3 units. So that's the second step. So we can do that. So it is y equal x. You can write plus 3 if you want, but remember this is going to go to the left side. And then what we have is the scaling factor. So we can go to the scaling factor next. So y equal negative 2 x plus 3 squared. Now only thing left is you can see y equal negative 2 x plus 3 squared plus 4. So those are the steps we're gonna go in every time. Good. So let's see what happened in each case. So that means we're gonna start with the basic function now. So this is the basic function. So we have y equal x squared. So this is the graph like this. It's a parabola. So you're gonna get that. That's the first one. And we have a 0 there. It's always important to identify certain important points. So that's the first one. What happened in the second one? You can see in the second one, it's graph gonna move 3 units to the right. That means the 0 gonna move to negative 3. That means if you look at the next graph, you can see that. So I'm gonna draw the axis like that. So you can see that 0 move to negative 3, and then your graph gonna go like this. So that's the shape of the new graph, but the 0 move to negative 3 because you move the graph 3 to the left. Okay, now what happened? Let's see what happened with this one. But it has two things. It has a negative sign. Negative sign means all the positive y values become negative y values. Negative y values become positive values. That means you're going to reflect about the x-axis. That's the negative sign. It's going to reflect about the x-axis. But 2 going to scale by 2 units. So it's going to scale by 2 units. So for example, so that's an interesting point. What is this point actually? So you can see if you want to find the y-intercept anytime, if you want to find the y-intercept anytime, just plug in x equals 0 to the corresponding function. That means if you plug in x equals 0 here, so you can see if you plug in x equals 0, you get 3 squared. That means this point is 9. So that's the y-intercept. But now what happened in the next one, since you multiply by -2, this 9 become -18 because the negative sign flip, and all 2 gonna scale it. So it's gonna, you just multiply the two numbers, 9 and -2. So you're gonna get -18. So that's where the graph gonna go, and it's also flip the graph. And then you can see, so the next graph, so I'm gonna graph it like that. So and there are no horizontal changes. That means -3 can stay at -3. Because we talk about in the transformation video, if it is an inside change, it is a horizontal change. If it is outside change, it is a vertical change. -2 is outside of the parent function, so that means it's only affecting vertically. Good. So what happened now is it's gonna reflect the graph. This original graph is gonna reflect, and also gonna scale it. So that means your new graph gonna look like this. Gonna go like that. And then what is this number? This number is -18. -18. It's also, you can find, just plug in x equals 0 here. So if you plug in x equals 0, you can see that 3 squared times -2, which is -18. Okay, now the final graph. So what's the final graph? You can see you need to lift this graph up by 3 units. So that's the last step we do. Okay, that's the last step we do. So once you do that, you can see you need to lift the graph 4 units up, and also you can find what is the new intercept. So what's the new intercept? Just plug in x equals 0. So you can see that it's a -18 plus 4. That means -14. So that means your new graph is, so you're going to lift this one by 4 units, and then yeah, so -3 stays at -3, no changes. So that means it's gonna go like this, it's gonna go up and then go down like that. Yeah, so good. Okay, so that's the final graph. So you can see, as before, this is -14. You can find plug in x equals 0, and this is -3, no change. And then the y-intercept is now at 4, because earlier it was at 0. Now it's moved up by 4 units, so now it's at 4. So that is the final graph. And then also it's very easy to find the dominant range, and this is a transformation of a polynomial, it's a polynomial, so that means the domain is all real numbers. So I'm going to write the domain range here. So domain of this function is, so domain of f is simply all real numbers, so it's -infinity to +infinity. But if you look at the range of this function, and you can see that the values go all the way to -infinity, but it can stop at 4. So that means it is -infinity up to 4. So that's the range, because you can see the maximally you can get it 4. Okay, that's how you use the transformations. So you write the several steps, and then try to write one by one. That is the best way to get it. And the plotting points is not really the right way to get graphs like that, because it's gonna skip all those key features of this one. So we use transformations as much as we can. Okay, so let's go to the next second part, part B. So we have GD equal 3 minus 2 square root t minus 5. So you can write this function like this. You can say this is exactly equal to, I mean, you don't have to, but you can write it like this. You can say this is -2 t minus 5 square root plus 3. If you want, you can write it like that. That's not necessary, but if it helps you, you can write it like that. Now let's start with the basic function, and you can see that if you remove those constants, you can see it's going to end up getting, so we're going to remove, if you disregard this, you can see that it's square root t function. That's the parent function. So we're going to start with y equal square root t, and then we're going to do the horizontal shift first. So that means it's going to go with y equal t minus 5 square root t. And then we're going to multiply by -2 as last time. So it's -2 t minus 5. So -2 are going to do two things. It's going to shift, it's going to reflect about the x-axis, and also scale by 2. And then finally we have y equal -2 t minus 5, and then what you want to do is just lift this function by 3 units. Okay, so now let's try to graph one by one. So here we know this is one of the basic functions again, so which is the square root function, so which is only in the first quadrant. So that's the function start with 0. And then what's going to happen in the second one, and you can see this -5, that means we're going to move to the right 5 units. So that means it's inside the function, that means a horizontal change. So it's going to change horizontally 5 units. So that means the new graph gonna look like, so it's gonna start with 5 now. So that means it's gonna go there and go like that. So let's start at 5. So that's the only difference. It's gonna move 0 to 5 now. Okay. And then in the next one, what's going to happen is a -2. So it's outside, that means a vertical change. So it's going to reflect about negative sign, going to reflect about the x-axis, and also scale by 2. So it's a scaling factor as well. So that means, so if you look at the graph, I'm going to shift the axis. So what happened here is 5 stays there, but it's going to reflect and then scale. So the graph going to go like that. So that's 5 stays the same. Okay, and then so the last thing gonna happen is you're gonna lift the whole graph by 3 units up. So that means you're gonna get so the graph the points gonna go up. So that means the final graph is, so I'm gonna move the axis like that just to make it easy to see. So it stays at 5, and then the 0 now, so we had a 0 there, now that's going to move to 3. So that means that's the new starting point, and then it's going to go down. So that is the final graph of that function. Okay. So you can see that it's not that difficult, but if you're going to go step by step. Okay, so here what happened is you move by 5 units, and what happened here, you're going to reflect this graph, reflect and scale by 2. Okay, so it's going to reflect side, and then it's going to scale by 2 units. Good. And then finally you lift the graph up by 3 units. Good. So let's look at the next one. So which is again we're going to ignore the constant terms, and you can see that you're going to end up with y equal absolute value of x. That is again one of the library functions, one of the basic functions. And then as before, you can see there's a horizontal shift by negative, so it's actually -2. That means gonna move the graph 2 units to the right, 2 units to the right, and then we have y equal -3x plus 2, x minus 2, not plus 2, x minus 2. So it's gonna reflect and scale by 3, reflect and scale by 3. So we can normally write it like this. So you know, reflect. Actually, arrow 2 arrows because positive become negative, negative become positive. So like that, and also scale by. So you can say times 3, scale by 3. Good. And then finally we have y equal -3x minus 2 minus 2. So it's a -2. That means gonna bring the graph down by 2. So let's graph each step. So this is one of the basic functions. This looks like a V shape. So it is y equal -x and y equal x. Those two are the functions. So that's the basic function. Y look like. So this is y equal x. This is y equal -x. Those two are the function on the two sides. This is one of the piecewise function. Okay, good. And then the next one, we're gonna move this one 2 units to the right. So this point is gonna change now. So it's gonna go there, and 0 now go to 2. So it's gonna go to 2. That means it's gonna go like that, and then go like this. Just still straight lines. And if you need to find what is this point, so you can see if you plug in 0, you get 2. So the y-intercept is 2 now. And then what happened, the next one is going to reflect this about the x-axis, and then also scale by 3. That means the 2 becomes -6 because you just multiply the two numbers. Y-intercept with -3, so you get -6. So that means it's going to give you like a kind of idea how we should graph it. So it's always it's a good idea to find the y-intercept every time. And the 2 doesn't have change because that's outside change, so no horizontal changes. So what happened, this is going to go to -6 now. It's going to go like that, and this number is -6. You can easily find this, just plug in 0 here. If you plug in 0, you can see that you get -6. Good. And then finally, you're going to shift this down by 2. That means this 0 going to go to -2 now. So finally, your graph going to looks like uh, so so the highest point, so now which was at 2, gonna go, and then also gonna go to -2. So that's the highest point now. And then this y-intercept gonna go to -8 now, because gonna -6 gonna go down by 2, so it's -8. So that means final graph is looks like this. Okay, because there are no shape changes because you just move. There cannot be any shape changes. Okay, so that is -8 now. Good. Yeah, so that is the top one. Actually, we forgot something. We need to find the domain and the range. So let's write the domain of the previous function, and you can see the domain of the previous function was, so this is 5, and you can see 5 and more. So the domain of this is the domain of G, which is 5 and up. So you can see 5 including. And the range, so what happened to the range? And you can see it's going to go to -infinity, and it's going to the highest point that you can get is 3. So the range of G is going to for -infinity, end up with 3. Good. And see how in the domain you write the infinity at the end. In the range you write the infinity -infinity first. Okay, because that's how it's gonna grow. Okay, and then for the next one, you can see here the domain of H, which is you can see this is square root the absolute function. That means you can plug in any value. So this is all real numbers. You can write curly r if you want, or -infinity percent infinity, and the range. So what's the range? Range of H, and you can see it's go all the way down to the -infinity, but the highest value you can get is -2, and you have all the values in between. So that means -infinity to -2, and you can see -2 is including, so it's including -2. So that's the range of that function. Okay, so let's look at the so the last one. So we have another very important functions here. So you can see again, if you ignore the constants, so you're going to get y equal 1 of x. So that is again one of the very important functions. These appear in physics and chemistry and biology and mathematics also a lot. Good. And then what's going to happen? You can see the next function would be y equal 1 over x plus 2. That's the next one. And then we're going to go for the scaling. So we have y equal 3 times the scaling factor x plus 2. So it's going to stretch the graph by 3 units. And then finally we have y equal 3 x plus 2, and then -4. Okay. So again, what happened here? We're gonna move to the left by 2 because of +3, plus 2, and then it's gonna stretch by 3 units, and then this is gonna shift down by 4 units. So and then we know the graph of 1 over x. That's again one of the basic functions. So this is what we normally call the rectangular hyperbola. So so this looks like this. So it's gonna go like that, and then go like this. This looks like these are what we call asymptotes. It looks like they're getting closer and closer, but it's never gonna go equal that the numbers. Never cross those axes. Okay, that's the basic function. And again, if you are not familiar with these, you can look at the video about the graph of the library of functions. And then what's going to happen? The next one, you're going to move the graph 2 units to the left. Um, so so I'm going to change the axis a little bit. So what happened here is, so you're going to move the 0 to -2 now. So how we do it, we normally draw like a dotted line to mean those axes. That's this axis we need. So the 0 now go to -2. So the new graph gonna look like that, and then on this side it's gonna look like that. So the 0 is there. So that is the x and y axis, but this is the new axis. So that's the new graph. It's gonna move to the left. Now this is gonna scale by 3. So for example, if you find what is this y-intercept, so you can see if you plug x equals 0, the y-intercept is 1/2. So what happened now? That 1/2 is gonna scale by 3. That means it's gonna go 3 halves. So that means the new graph is uh, just the scaling, and this is the axis, y-axis. This is the x equal negative, the what we normally call the asymptote. So what happened now is it's gonna 1/2 now become 3 halves. So it's gonna go like this now. So it's gonna just scaling. It's gonna just scale. So that's what happened. So this is still -2, and this point now is 3 halves. You multiply by 3. Good. So finally, you're gonna bring the graph down by the whole graph down by 4 units. So what happened? It's gonna simply change the values. So so there are no so it's like a so there are no horizontal changes. This is a vertical change. So we can find what is the new point, new y-intercept, and then this negative stays the same because it's outside change. That's still -2. So we can find what is the new y-intercept. So it was at 3 halves. You subtract 4 from that, so it is -2.5. And then also, what is the new horizontal line? So you can see it was at 0 earlier, but it moved down by 4. That means it is at -4 now. This is as -4 now. So this is -4 because 0 now go down to -4. Okay, so so the new graph, now you can graph like this. So it's gonna go like between these two lines, and then between those two lines. Good. Okay, so that is the new graph, and then you can see what this new point is -2.5. So that is the new y-intercept. So that is the final graph of that. So you can see it's very easy if you go step by step, and you can see that you cannot get a like a neat graph like that using the plotting point technique. You have to use the transformations. Okay, so and you can see what's the range now. And first, what's the domain here? You can see the domain of this graph is everything. You can say you can plug in 0, so everything except 0. So you can write this one as is all real numbers except, so you remove 0. So that is one way to write it. And then the range, and you can see that range is also it's never become 0. So it's all real numbers except, so you remove 0. So that's a range. But in the final graph, and you can see that so the domain of the graph K, so you can see you can plug in everything except you can see that at -2 there's no value, so you have to remove -2. So that means R, you remove -2, everything except -2. And for the range, for the range, and you can see that it never get equals to -4. You never get the -4. So it is r minus -4. That's one way to write it. And also you can write this one as, for example, you can say -infinity and then at -4. So you remove, that means open, and then union, and you can see -4 all the way to infinity. So you can write it like that, and you can write a similar one for the domain also. So that is the graphs and the domains. Okay, so let's go to the next problem. So we have the factoring method. So this is one of the another method to solve a quadratic equation. So we're going to use the factoring technique. So let's start with the first one. So what it says that 2x squared plus 5x plus 3 equals 0. So what you're gonna do, you're gonna multiply these two numbers. So it is 2 times 3, which is 6. Now the goal is to find two numbers. When you multiply, you get 6. When you add, you get 5. You get the middle term. Okay. So what are those two numbers? And you can see that those two numbers are exactly the same. So it is 2 and 3. So those are the two numbers, because you can see when you multiply, you get 6. And when you add, you get 5. So how we normally do it, we're going to rewrite a 5x using those two numbers. So it is 2x squared. Instead of 5x, now you can write 2x plus 3x. That's the whole point. Where are those 2 and 3 coming from? And you can see 2 and 3 are those two numbers. And then you write the other number, 3 equals 0. Now what we do, we use, after that, we can use the grouping technique. So we're going to group in the first group, you're going to find the common factor, which is 2x. So you get x plus 2. And from the second term, you get it's x plus 1, not 2. So you're going to get x plus 1. And from the second group, you get 3 out. So you get x plus 1 again, which is equal to 0. And now what we can do, we can write the common factor, just the common factor, x plus 1. And then we can write these two numbers. So it is 2x plus 3 equals 0. Okay, so 2x and 3. So we're going to write those two numbers there. Good. Now after you factor, that's a factoring. Now what we do, you set each factor equals 0. So what this means, x plus 1 equals 0, or 2x plus 3 equals 0. And then this says that if you subtract 1 from both sides, x equals -1. Or how to solve this one? You first move plus 3 to the other side. That means it's going to be -3 and then divided by 2. So that means you're going to get x equal -3 divided by 2. So that's the answer. So you can have the solution set. So the solution set, the solution set is, you can write it as a set, because it's a solution set. It's a -1 comma -3/2. You can write it like that as a solution set. Okay, so that's how we use factoring method to solve a simple problem like that. So let's look at the other problem, the second one. So what it is, you can see the variable is t now. So we can do the same thing as before. Look at the two numbers. We have 4 and -3. So it is 4 times -3, which is -12. And again, you try to find two numbers. When you multiply, you get -12. And when you add, you get -1. So that means those two numbers should be -4 and 3. Because when you have -4 and 3, you can see when you multiply, you get -12. When you add, you get -1. We can see there's -1 here. So when you add, so that means a -4 and -4 and 3. Now, as before, we're gonna replace the middle term by those two. So it is 4t squared. Instead of negative t, we write -4t plus 3t minus 3 equals 0. And then we use the grouping. So we're gonna get 4t as a common factor. So you're gonna get t minus 1. and then you're going to get 3 out, t minus 1. So the whole point is to get the same term. So if you do not get the same term, there was a mistake somewhere. Okay, now we're going to write the factors as a 4t from the first one plus 3 from the second one, and then write the common factor, and then set each factor equal to 0. So after this you can write like this. You can say it is 4t plus 3 equal to 0, or t minus 1 equal to 0. You may wonder why we say O. So the reason is that for a product to become 0, since the product becomes 0, you only need one of them to be equal to 0. That's why we say O. It's not an AND. Say O, because one of them. It can be both, but we don't need that. We only need one of them. So we're going to say this or that. That's why I say O. Okay, now after that, we know how to simplify this one. If we move the 3 to the other side, which becomes negative 3, and then divided by 4, so that means the answer becomes t equal negative 3 over 4. That's the first one. Or if you add 1 to both sides, become 1. Okay, so those are the two solutions. And the last one. So in the last one, again, same argument. We can look for the number which is 16. So you can think about 16, how to write, how to find two numbers. When you multiply, you get, 16. When you add, you get negative 4. You can see those two numbers are negative 4 and negative 4. You can see when you multiply, you get 16. When you add, you get negative 8. So, and then since you know those two numbers, you can actually directly write for this one. You can directly write the factors here. But if you want to see how we do it as before, it is x squared. You write minus 4x minus 4x. That's the replacement of the middle term plus 16, and then do the grouping for the two terms. So from the first one, you pull x out, so you get x minus 4. And from the second term, the goal is to create this term. That's the goal. You try to create the exact same term. So that means if you want to create the exact same term, you can see that you need to pull negative 4 out. So then you're going to get x. So what we normally, pulling a term out means you take, you divide by that term. That means if you divide 16 by negative 4, you get negative 4. Good. And then you can see these two are the same. If they are not the same, you cannot continue. You have to stop there because something wrong. Now you see that this term is, you can write the common term, and what you get is x minus 4 again. So it is a special situation. And then, so this simply x minus 4 squared. So that's a repeated factor. So now the answer is you set this equal to 0. So this says that x equal 4. But we normally call the with multiplicity 2 because there are 4 twice. So the answer is, you can say x equal 4 with multiplicity with multiplicity 2. Good. So that's how you use a factoring method to solve a problem like that. Good. So let's move on to the next one. So this is a factoring technique. The next one would be, the problem says use the completing square method. Use the completing square method to find the zeros. So theoretically, what it's asking, find the zeros means what we normally do is we're going to set the function equal to 0 and then solve for x. Solve for x. So we can do it here. So that means we can set the function equal to 0. So it is 3x squared plus 6x plus 2 equals 0. Now when you want to do the completing square method, so there are like a certain steps that we normally do for these kind of problems. So the first step is we try to move this term to the other side. So that means we have 3x squared plus 6x, and then we move that term to the other side, so which is negative 2. Now, since this is not 1, you're going to divide by that term. That's the second step. So that means you can divide by 3, so it's going to x squared. If you divide by 3, this is going to be 2x, and then this you can divide this one by 2 also, it's going to be 2 over 3. So that's what happened in the next line. Now what we're trying to do, we try to find the special term. What the special term is, we can take the half of the coefficient of x, so that means it's a plus 2, so you divide by 2, and then we can square that. So with half of the coefficient is squared, in this case is 1, so that means we can add that 1 to both sides. That's the next step. That's a special term. Special term. This is 1 in this case. Now when you do that, what happened, this side simply become a complete square. So this is a complete square. So what is the complete square? It is x plus half of the coefficient, which is 1 squared. And you can see that if you use the if you distribute this, you exactly end up getting that term. That's always the case. Always x half the coefficient squared. On the other side, we're going to simplify. When you simplify, you can see that this is negative 2/3 plus 1, that means 1/3. So you get 1/3 there. And if it is not clear to see that, what you can do, you can get the common denominator, just multiply the top and bottom by 3, and then you can see that same denominator, and the top become 3 minus 2, which is 1. Now since after we get to this one, what we can do now is we can take the square root of both sides. So once you take the square root, what's going to happen, this is this square, so you're going to get, once you take the square root, okay? So you take the square root. Once you take the square root, what happen, you're going to get plus or minus square root of this, but this you can easily simplify, which is plus or minus square root of 1 means 1, square root of 3 means so 1 over square root of 3. That's what you get. Now finally we're gonna subtract 1 from both sides. So once you subtract 1 from both sides, you get x equal negative 1 plus or minus 1 over square root 3. So that is the final answer. So using the completing square method. So you go through a completing square. Okay, so this is where you read the completing square. Okay, so that's the complete square. Completing square. Good. Okay, so let's do the second problem. So as a second problem, we have this one. You may not like it, what you have here. So I'm going to solve, actually you can solve this problem in a different way also. I'm going to use the second method to solve this problem. What's the second method? We are not going to set to equal to 0 at the beginning. We do that at the end. So let's do that. So we're going to use a second method. I'm going to call this a second method. Second method. So earlier we used the first method. In the first method, what we did, we moved the constant to the other side. But you don't have to do that. You can keep it there, but you can see the algebra is slightly different. So let's do the second method now. So what we're going to do, we're going to start as before, and then you can see that you see the negative 1/2, which is not 1. So what we're going to do, we're going to factor out that only from the first two terms. So let's do that. So I'm going to factor out that. So when you factor out 1/2, factor out 1/2 means you divide by negative 1/2. Divide by negative 1/2 means multiply by negative 2. So that's the argument. So so divide by, so what we are doing here is you divide by negative 1/2. Divide by negative 1/2 means you can multiply the top and bottom by 2, negative 2. So what happened when you do that? So you can see negative 1/2 times negative 2. You can see this get cancelled out. You can see the 2 and 2 get cancelled out, and negative become positive. So you simply end up getting negative 2. So that means dividing by negative 1/2 is exactly equals to multiplying by negative 2. So you can remember this as a trick sometimes. So you can simplify certain algebra like fast. So, okay, so you good. So now what we're gonna do, so we can divide by negative 1/2. That means from the first term you only get t squared, and then divided by 1/2 means negative by multiply by negative 2. That means you got negative 6t. So we can leave some space, and then that's the 8. So we just write it like that. You can see we just rewrite that term. Now we need to find the special term. So what's the special term? The special term is half of the coefficient of t squared. So that means which is negative 6 over 2 squared. Negative 6 over 2 means 3 squared means 9. So 9, we're going to add 9. But be careful, you add 9 and you cannot just add negative 9 to the other side, because you can see in front you have that special term. So that means it's not just 9, it's 9 times negative 1/2. That means negative 9/2, negative 9 over 2. So just to cancel that, we add positive 9 over 2, because you are simply adding these two, the product of this. But what's the product of that? Which is negative 9/2. So what you want to do is, to cancel that, you add positive 9/2. So you can see this algebra is slightly different from the previous one. Okay, good. Now, so we have this, so which is negative 1/2. And then this is automatically t, half the coefficient, which is negative 3 squared. So automatically. And then this side you can simplify. When you simplify, how to do it? You're going to multiply these two and add those. So that's what's going to happen. So it is 8 times 2 is 16, plus 9 means 25. So you're going to get 25 over 2. That's what you get. Now you can see at this level, the completing square is done. Actually, I'm going to repeat this number here just to get some space. So yeah, so this is negative, this 9. So let's remove this from here. Good. So that's what we have. Now you can see this is the completing square we were talking about. So that's the completing square, this line. Now what we do, so after we get to the complete square step, now we're going to set this equal to 0. That's what we can do. So let's set this equal to 0 now. So that means it is negative 1/2 t minus 3 squared plus 25 over 2 equal to 0. That's, you set it. Okay, you set. We are looking for zeros. So you set it equal to 0. Good. Now we're going to solve. How to solve it? You're going to move the constant term on the other side. So which is negative 1/2 t minus 3 squared, mu means negative 25 over 2. Now we're going to remove this. To remove that, you're going to multiply both sides by negative 2. So that means it is t minus 3 squared negative 25 over 2 times negative 2. So, and then you can see this get cancelled. So you end up getting 25. And then what we do, we take the square root. Consider the square root. It is t minus 3 again plus is equal. You can see I say even power, so that means you're going to get plus or minus. So plus or minus square root of 25, which is 5. Now we're going to add 3 to both sides, so it is t equal 3 plus or minus 5. And what we can do, we're going to go with each factor separately. So we have t equal 3 plus 5, which is 8, or t equal 3 minus 5, which is negative 2. So that means these two are the answers. So you're going to get t equal 8 or negative 2 as the answers. Good. So that's about that. So let's go to the next problem. So we're going to use the so what it says that use the quadratic formula. Use the quadratic formula to solve the following equations. So what is the quadratic formula? So when you have ax squared plus bx plus c equals 0 with a not equal to 0. So the formula says that the solutions are given by negative b plus or minus b squared minus 4ac square root whole thing divided by 2a. Since we divide by a, that's why we need we want to make sure that a not equal to 0. That's a quadratic formula. So we can use this formula to solve our problem. So actually, in theory, you can solve any quadratic equation using the quadratic formula, anyone. But sometimes there are shortcuts, like for example, factoring sometimes work much faster. But in theory, you can always use quadratic formula to solve problems like that if a not equal to 0. So let's start with the first one. So the first one says x squared minus x minus 3 equals 0. So if you get a problem like that, what we're trying to do is we can identify the ABC. So in this case, A equals 1, B is negative 1, C equal negative 3. It has to be in that order. So that's very important. And also we're gonna use the signs also. Good. Now what we're gonna do, we're gonna plug in that in the equation. Um, so you can see. So if you plug in these, you're gonna get x equal. So it's a good practice to rewrite the equation, which is b squared minus 4ac square root over 2a. So we're gonna plug in here. So if you plug in, you're gonna get negative. B means negative 1. When you have a negative 1, make sure that you use a parenthesis. So it's a good practice to do that, because sometimes many students lose points because they forget the parenthesis and write something else, and and everything is wrong after that. So it's a good practice when you see a negative sign, especially when you multiply, make sure that you write the negative sign here. Okay, the plus or minus, and then you can see this is inside you have negative 1 squared minus 4 times a means 1, c means negative 3 square root over 2 times a means 1. So let's simplify this a little bit. So you get negative positive. So here you get positive 1, and then plus or minus, we still don't know. 1 squared means 1, and then you have two negative signs. So it's positive, you get 12. 4 times 3 means 12. So it's positive 12. So that's what you get over 2. And then you can see plus 1 plus 12 is 13. So that means finally you get 1 plus or minus square root 13 over 2. So those are the two solutions, and you can, if you want, you can separate them, or you can leave it like that. So and if you have the solution set, so the solution set, you can write 1 is 1 minus square root negative square root 13 over 2, comma 1 plus square root 13 over 2. So that's the solution set. But if you just need a solution, you can write like that. And it's always a good idea to kind of go back and check, because you can see whether there's a mistake, because this should satisfy the equation. But that's how we solve using the quadratic formula. It's very straightforward. So let's look at the second part. So which is 1/2 x squared minus 3x plus 9/2. So again, we directly use a formula, but so for example, you can see these numbers. I mean, you can directly plug in a equal 1/2. So if you look at this original one, you can see a equal 1/2, and then b equal negative 3, c equal 9/2. So there's nothing wrong with using ABC like that, but we can make this equation much simpler. How to do that? You can see, if you have an equation, you can always do, like for example, you can multiply this whole equation by a constant except 0. It doesn't change the solutions. You can add a number to both sides. You can do all those algebra to these. You can multiply by a non-zero number. You can add a constant to both sides. You can do anything. It doesn't change the solution. So because of that argument, what we can do, we're gonna we can remove this 1/2 from the equation just to make it easy. So what we're gonna do, actually what we're trying to do, we try to multiply by the least common denominator. We're gonna look at all the fractions. We're gonna multiply by the least common denominator. So yeah, so that's the trick. So multiply by the least common denominator. Multiply by the LCD. to make it easy. So that's exactly what we do in this case, because you can see 1/2, and then also this also has a 1/2, so the LCD simply become 2. So we multiply by 2 the whole equation. Once you do that, you're going to get x squared minus 6x plus 9 equals. This is much simpler to solve than the original one. So we just multiply by LCD to make it simple, and then because it doesn't change the solution set. So now we're going to use a formula. So but in this one you can see now a equal 1, b equal -6, and then c equal 9. These are much simpler compared to the original one. So the solution is x equal in this case negative b, which is you can say negative b, which is -6, and then plus or minus b squared, that means -6 squared, that means 36, and then minus 4, a means 1, c means 9, square root over 2 times 1, and you can see you get 6 plus or minus, and you can see what happened inside is you get 0, so square root 0, which is 0 over 2, so that means you get 3 as a repeated factor. Okay, so you can say with multiplicity 2, with multiplicity 2, because it's repeat twice. Okay, good. So that's the solution. That means x equal 3 with multiplicity 2, because it's going to repeat one more time. Good. So let's go to the next problem. So in this one we can see a equal 4, b equal -3, and c equal 5. And you can kind of see something, because there's a small b and large a and c values. That's kind of going to give you a negative discriminant. So let's calculate the discriminant. So if you look at the discriminant, b squared minus 4ac, so which is -3 squared minus 4 times a means 4, c times 5, so which is 9 minus 4 times 4 means 16 times 5 means 80, so which is -71. So you get -71. So since this is negative, there are no real solutions. So there are complex solutions. So there are no real solutions. Okay? There are no real solutions. So what we can do is we can still use the formula. So that's the benefit. So it is negative. So it is negative b. So -3 plus or minus. And then since we calculate the b square minus 4ac here, which is -71 square root over 2a, which is 2 times 4. So, and if you write this as 3 plus or minus, what we normally do is if you get a term like that, we can write 71. A -1 is replaced by I squared square root over 8. And you can see, you can simplify this as 3 plus or minus. So we take the square root of both terms, so there are 2 terms there. If you take the square root of first one, which is 71 square root, I squared means I, so we write it like that, and divide by 8. So that is those are the two complex solutions to what we call complex solutions. And if you need more details, you can find the video that is that discuss how to solve certain equations using the quadratic formula, and you can find more examples there, and how to use how to solve for repeated solutions, and how to solve for complex solutions. Okay, so that's about that. So let's move on to the next problem. So when you want to find a intersection points, what does that mean? So for example, let's look at a situation. So let's say you have two graphs. So this is like one graph, and there's another graph. So we are looking for the intersection point. So in theory, what happened at the intersection point? So let's say this is the y equal fx and this is y equal gx. So what happened at the intersection points, you can see the two y values are the same. So that means fx equal gx at that point. So in theory, what we're gonna do, we're gonna set them equal. So we're gonna set them equal and solve. And then after that, we're gonna solve. So that's what we do in theory. So we can use that here to solve those two problems now. So as the first one, let's look at this. So we have fx um, equal to x squared minus x plus 1, and we have gx, which is x plus 5. Since we are looking for intersection points, we set them equal. So if you set them equal, you get 2x squared minus x plus 1 equal x plus 5. So that's the first step. So the next thing what we're going to do is we're going to bring all the terms to one side. So if you bring all the terms to one side, that means you're going to subtract x and subtract 5 from both sides. So you're going to get 2x squared. Subtract x, you get negative 2x. And then if you subtract 5, you get negative 4. So next thing we can do, you can see that you can divide by 2. Always look for ways to simplify. So if you divide by 2, you get x squared minus x minus 2 equals 0. Now either you can use a quadratic formula or use the other methods such as factoring. And you can see this one is easy to factor. The number is negative 2. You're going to find two numbers. When you multiply, you get negative 2. And when you add, you get negative 1. So the two numbers are negative 2 and 1. So that means the two factors are x negative 2 and x plus 1. Those numbers directly go here. You can see that's the negative 2 and 1. Okay, once you know those two numbers, they directly go there. Now what we're going to do, we're going to set them equal to 0, each of them. And then, you can see, so we're going to set x minus 2 equal to 0 or x plus 1 equal to 0. This says that x equal to or negative 1. The next thing that you need to do, because you're asking the intersection points, these are just the x values. So these are just the x values. If you know the intersection points, what we normally do, we're going to plug in these values to one of those functions and find the corresponding y value. So what we're going to do, we're going to normally plug into the easy one. So easy one is, you can see this is the easy one. So we're going to plug into this one. So it doesn't matter which one, but that's the easy one. So we're going to say for x equal to, we have g2, so which is 2 plus 5, which is 7. So that means the point is 2, 7. That's one of the intersection points. Now for x equal negative 1, g negative 1, which is negative 1 plus 5, which is 4. So that means the other point is negative 1, 4. So those two are the two intersection points. So these are the intersection points. Intersection points. Good. So let's look at the next one. So which is fx equal 3x squared minus 6x plus 1 and gx equal x squared minus 2x minus 7. So we do the same thing. We can set them equal. So we have 3x squared minus 6x plus 1 equal x squared minus 2x minus 7. And again, try to bring it to one side. So we subtract x squared, we get 2x squared. And then subtract negative 2x, that means add 2x, that means negative 4x. And subtract negative 7 means add 7, so it gets 8 equals 0. Again, there's a common factor, we can divide by 2, so you get x squared minus 2x plus 4 after divide by 2. Now we try to find factors. and then you can see that it's not because what you need is you need to find you have 4. When you multiply, you should get 4, and when you add, you should get -2. And you can see that there are no such numbers. So, so let's look at the discriminant. So, which is b squared minus 4ac. So, b squared means -2 is squared minus 4 times a is 1, c is 4. And you multiply, you get 4 minus 16, which is -12, which is a negative number. What does that mean? There are no real solutions. Okay, there are no real solutions. What does that mean? These two graphs never cross each other. There are no intersection points. So that means, in practice, it means that there are no intersection points. Points. So there are some graphs like that, they never cross each other. So that is a kind of a situation here. Good. And now you may wonder, how can that happen? So like, for example, one of the easy case would be something like this. So let's say you have two graphs. One graph is like, say, going like that. The other one is going like this. So in this case, you can see that they never cross each other. But here you can see that the both graphs concave up, like both going up. So that means, how can that happen if both going up? So you can see a situation like this. So let's say this is one graph going like that. Maybe the other graph is going like this. So you can see that those two graphs does not cross each other. So that's the kind of situation we have right now. So so they never cross each other. Good. So let's go to the next problem. So what it says that this is like a different type of problem. So it says that find the standard form. So when you find the standard form with the quadratic function, that means there is a special format that we talk about. So that means fx equal, we have to rewrite this equation as a constant x minus h squared plus k. So this is what we call the standard form. Standard form. Now the question, how to rewrite it like that? So what we normally do, we use the completing square method. So use a completing square method. Use completing square method. Good. And if you are not familiar with how to do the completing square method, and there's a video in the description, and that solves like about 4 different examples and how to do that in a different situation with different type of problems. Okay, so let's work on this problem right now, and it's also asking find the vertex. So the vertex is simply hk, so that's the vertex. Yeah, so once you do the completing square, so the vertex simply becomes h and k, and then also we can find where it's increasing and where it's decreasing depending on the shape of the graph. Because what happened, like, so if the graph is like this, and you can see, so that is the hk, and you can see it is increasing on this part up to here, and it is decreasing on this part. And if the graph is going like this, now you can see that's the hk, and you can see so the graph is decreasing on this part and increasing on that part. So yeah, so that means we just need to find h and k, and then we can answer all those questions. Okay, so let's try to see how we can do the problem. We can use the completing square method. So we can start with fx equal -3x squared plus 6x plus 5. And how we do it, we try to factor, if this is not 1, we try to factor this term from the first two terms, just the first two terms. That means we factor -3 out, you get x squared. Factor out means you divide by 3 inside, that means you're going to get negative 2 here. When you divide 6 by negative 3, so you divide 6 by negative 3, which is negative 2. Let's say again negative 2. And then we're gonna move 5 over there, and then we try to find the special term. The special term is half of this squared, so which is negative 2. We're gonna take half of that and squared, and you can see it is 1. So you're gonna add 1, and then when you add 1, what's exactly happen is you can see you actually multiply by that. So you are not really adding 1, you are adding negative 3. 1 times negative 3. To cancel that, we add positive 3. Okay, you add in negative 3. To cancel that, you add positive 3. So that's what you get. And then you can see right after we do that, this is negative 3. This is automatically square. It is x. The half of the coefficient, which is negative 1 squared, plus 8. So you can see this in the standard form. So that is the standard form. Standard form. Good. And then you can see this is the h value, and that is the k value. Okay, good. So this is in the standard form, and they find the vertex. So the vertex, which is hk equal 1, 8. So it's 1. It's not negative 1 because you have to write the negative h. So that without negative signs is 1, 8. So that's the vertex. And then also on what interval it is increasing, and you can see that here a is, which is negative 3, which is a negative number. So that means it is concave down. So concave down. Concave down means the graph is like that. So that is the hk. So that means it is decreasing on this interval. So that means it is from h to positive infinity. So decreasing, so on actually as increasing. So increasing on this interval. So increasing on this interval. So it is negative infinity to all the way to h. So increasing on is asking increasing, not decreasing. Increasing. So increasing on negative infinity to h. That means negative infinity to 1. Good. So that's how we answer a question like that. Good. So what the method we use is completing square technique. Okay, let's go to number 8. So in this problem, so you have a quadratic function. You have to graph it. But we can graph it using this technique. We try to find the vertex and the axis of symmetry and the intercept. Because if you know the intercept and the axis of symmetry, then you can reflect about the axis of symmetry and you can get the rest of the graph. So that's the kind of idea what we do. So for example, so let's say, so this is the graph. So let's say we have a vertex, and let's say this is the y-intercept. So if this is a vertex, that means this is the axis of symmetry. So what we can do, since we know one point, the other one has to be exactly on the other side of the axis of symmetry, because that's axis of symmetry. Now what we're going to do, since you know those 3 points, then we can draw the graph that passes through these 3 points. So that's the kind of idea how we use these 3 ideas. So if you know the vertex, and if you know the axis of symmetry and the y-intercept, then what we can do is you can reflect the point and you can just connect those 3 points and you can get a graph. So that's the method we use in those 3 points: the vertex, axis of symmetry, and the intercept. But if you get a problem like that, again, how we can find those vertex, axis of symmetry, and intercept, as we discussed in the previous problem, one method is use the completing square. So you can use the completing square method. So that is one idea. The other idea is we can directly use the theory, because we know that. So if we have a function fx, which is ax squared plus bx plus c with a not equal to 0, we know that the vertex, so what the theory says that the vertex is simply, which is hk, what we normally call hk, which is simply negative b over 2a, that's the h, and then the what is the k? You plug in that function value back into the equation, that's going to give you the k value. So that's the h value, and that's the k value. So this is the k. So you plug in that h value to the k function. So that's the k to the function. So that is the vertex. Once you know the vertex, and then also because we know that the axis of symmetry is simply x equal h. So once you know the h value, just set x equal h. That's going to give the axis of symmetry. To find the intercept, you simply plug in x equals 0. In this case, you get 3 for this problem. So that's always you can find, just plug in the x equals 0. So that's what the theory says. So since we used the completing square in the previous problem, let's try to use the vertex method for this one. So so what we have for this problem is, we have a equal 1, b equal 4, and c equal 3. So the h is simply negative b over 2a, so which is negative. You can see b equal 4 over 2 times a equal 1. So that means negative 2. So that is the vertex. That's h value. And then to find the k value, so k, which is simply f negative b over 2a. So in this case, f negative 2. So you plug in negative 2 into the equation. So you see that negative 2 squared plus 4 times negative 2 plus 3. And if you simplify, you get 4 negative 8 plus 3. So that means so 4 negative 8 plus 3. You can see that which is negative 1. So which is negative 1. So that means the vertex. So we have everything we need now. So the vertex is a negative 2, negative 1, and the axis of symmetry, which is x equal the h value, which is negative 2, and the intercept. So you can find intercept very easily. So the intercept, which is you can find x equal 0, that means y equal 3. So intercept is at y equal 3, the y-intercept. We just say y equal 3, or you can say 0, 3. Yeah, it would be better to, because that's a point. So you can say it is 0 and 3. Okay, so we have all three information. Now we can easily find the easily graph the function. So so we have the vertex, which is at negative 2, negative 1, and then axis symmetry is negative 2, and then the intercept is 3. So let's try to look at the graph. So we have this, and then also a is positive. Since a is positive, it's concave up, so it's going up because a positive. A positive means you get a graph like that. So so having all those information, now we can easily graph the function. So what we're gonna do, we're gonna mark the axis of symmetry, which is x equal negative 2, and also you can see there's the vertex is at this point, which is negative 2 and negative 1. So that is where the vertex is. And also we know that y at 0, 3, you're gonna see the y-intercept. So that is 3. That means you have to have 3 again on the exactly on the other side. So that means so this is negative 2. That means negative 4. At negative 4, you also should have a 3 there, because it's axis of symmetry. That means be symmetric about the axis. So that's the other point you're going to see. That's as negative 4, because it should be equal distance. So because there are 2 distance here, so this also has to be 2. That's why it's negative 4. Good. Now since you know those 3 points, you can connect the dots, and then you can get the graph like this. So that's the so it's going to be like that. It's going to go like that, reflect, go like that. So that is the uh, graph of the function. Good, so we use the vertex, axis of symmetry, and the intercept method. Okay, that's number 8. So let's go to, so if you need more examples, and you can find these in the quadratic function video. So we have solved similar problems over there. Okay, so let's go to the next problem. Next problem is about inequalities. So we're gonna do like a quite different examples there, because there are different type of inequalities. So we will make sure that we can understand this well. So let's go to that. So these are the problems that we try to solve. So these are solve the inequality. So solve the inequality means, so we need to understand what that mean. So solve the inequality means we know that not like a solving inequality is completely different from solving an equation, because when you solve an equation you get discrete values, you get several number of values depending on the degree of the equation that we're going to solve. So if it's like a degree 2, you will get either 2 or 1 or 0 real solutions. If you degree 3, you can get up to 3 solutions, degree 4 up to 4 solutions, like that. But when you solve an inequality, the solution set are intervals. So that's one thing we need to remember. The solution set are intervals. Solution set is an interval. So that's the major difference between a equation and an inequality. So you get always intervals. So that means, yeah, so that's why asking this interval notation, or you can show always that on a number line. When you solve an inequality, you can write the solution in like several different ways. Like in general, there are 4 ways to write the solution. So like you can write the interval notation. You can show in a line, and you can use a set builder notation, or you can explain in word. So those are the 4 different techniques when you solve a equation, when you solve an inequality. So here we can use the interval notation and the line technique. Okay, so so let's start one by one. And also there's another video, but if you get like a general inequality, you can solve that in 3 different ways. If you want to solve an inequality, you can solve inequality in 3 different ways. One is what we call the algebraic technique. Second one is what we call the sign diagram method. The third one is the graphical technique. So there are 3 ways: the algebraic, sign diagram, and graphical technique. So you can look at more examples in the video, and you can find the link in the description. So here we're gonna just go with the sign diagram technique, because that's much easier. Um, so that's what we're gonna use for solving these problems. But in general, there are 3 techniques to do it. So let's start with the first one. So as the first problem, we have 2x minus 3 greater than or equal -7. So what we're trying to do in a problem like that, we try to isolate the x term. So we try to isolate the x term. So that means we're going to add 3 to both sides. So we have 2x. Once you add 3, -3 get cancelled. You have -7 plus 3. So which is -4. So if you rewrite it, you have 2x greater than or equal -4. Now what we try to do is we try to divide by 2. But since 2 is a positive number, when you divide, it's not going to change the inequality. So it is -4 divided by 2, which is -2. So what this says is that x greater than or equal -2. That's the solution. That means the solution is any number which is equal or greater than -2. That means if you draw it on a number line, you can see that so it's gonna be like this. So that's the number line, and then we have -2 here. So what it says that the answer is a -2 equal or more. This is larger. It says that x is larger than -2. So that means that's the solution. So we draw this as a solid line. Okay, so that's the -2. So that is the graphical solution. And then the algebraic one, you can say, so the solution is, if you use the interval notation, so it is close at -2 and go to infinity. With infinities, we always write as opens, because infinity is not a number, it's never equal anything. Okay, so that's the interval notation for the first problem. It's negative infinity to 2, -2 close, because the 2 negative is included, and that's the The other one is the graphical version. Okay, good. So let's do the next problem. So that's the linear one, that's easy. So in the second one, that means if you have a linear one, you can solve like this. But the problem in the field of the second one, that's not linear, that's a quadratic. That means there are two linear solutions. So what we're gonna do, if you get a problem like that, we're gonna use the factoring. So we factor. So we get a problem like that, factor. That's what we do. So let's factor this, and we know how to factor this kind of problem. So 15. So you have 15. So you need two numbers. When you multiply, you get 15. When you add, you get 8. It's clearly 5 and 3. Those are the two numbers. That means you can write the factorization, which is x plus 3. Those numbers directly go there. X plus 5. Those are the two numbers greater than 0. So we know that there are three methods to solve an inequality. So we can use the sign diagram technique because that's much easier. So we draw a line and then put the two zeros. So you can see the two zeros are, so the first one says x equal, so if you from the first uh, um, factor, you're gonna get that x equal -3. From the second factor, you get x equal -5. So we're going to put those two numbers here in that order. So -5 and -3. Now what we're going to do, we're going to pick a test point and plug in. So what are the test points that we can use? So you can use a test point here, 0, because 0 is on this side. So if you plug in 0, and you can see that what you can do, you're going to plug in 0 to the either parent factored version or the original version. It doesn't matter, but if you factor, it's much easier to see. So if you plug in 0, you get you get +3 and +5. So that means positive positive. Since you multiply, positive positive is positive. So that means on this side is completely positive. Now you plug in a number in between, so I can pick t equal -4. That is the test point you're going to pick. So if you plug in -4, you can see the first bracket going to give you -1. The second one going to be +1. So negative positive means negative. So that means here is negative. And then for the other one, you can pick t equal -6. So if you plug in -6, you get -3 and -1. That means negative negative, which is positive. So that is the sign diagram. This is what we call the sign diagram. So sign diagram. Now you're going to pick what you need. So you need to find the interval where the sign is positive. So you can see that happen here and there. So the solution is you write from -infinity and all the way up to -5, and you can see that shall be greater. That means not included as open. And then we put a union sign, and then we write from -5, not -5, -3. All the way up to infinity. So that is the interval notation for this one. And the graphical notation, that's easy. So it's just the same sign diagram. So we write it like that, and then we can mark those 2 points. So we have -5 and -3. So that means your answer is like you have to mark, you make those two sides solid. So that's one. And then this one. Okay, so this is -5 and -3. So that's the answer in on a number line. And also you can also use the other one. Some people try to use the circle notation. That's also okay. So we can write so open circle, and open circle means the point is not included, and then we're gonna make this solid. So we can write it like that. So that's the answer. So this is -5 and this is -3. So you can use one of them. Okay, just use one of them. Good. So let's go to the next problem. It's very similar. Like try to bring it to one side and factor it. Then we can do this for any problem like that. So it doesn't really matter what is the problem. Good. So let's look at the next one. We have t squared minus t minus 2. So again, we can do v factor. So what are the factors for that? So you can see you have -2. So when you find two numbers, when you multiply it's -2, when you add it's -1. The two numbers are -2 and 1. That means the factors are t minus 2 and t plus 1. Directly those numbers goes there when the coefficient of t squared is 1. If it's something else, you cannot do this. So you can just put the two numbers there. So that's one number, that's the other number. It always works. Good. Now again, the zeros, you can see what are the zeros. So the zeros are t equal to and negative 1. So what we do, we put them on a number line in that order. In the smaller to larger, so it is negative 1 and 2. Now we pick test points. So so we can find the test points. So here you can say t equal 3 would be a good test point. So if you plug in t equal 3, you can see you get plus 1 and plus 4. So plus plus, that means this is plus. And then here in the middle, you can say t equals 0 as a test point. So if you plug in 0, you can say negative positive, so which is negative. And then here you can have t equal negative 2. You plug in negative 2, is a negative 4, negative 1, so negative, negative, positive. So so one thing happen is always you can see positive outside, negative inside. So you can see that this is positive on this and that, negative on in the middle. So that's always happen when you have two factors like that. So positive outside, negative inside. Good. So now since we know this one, then we can write the solution now. So what we are looking for, where it is negative, you can see it's negative inside. So that means the solution is, so you can write as an interval, so it is negative 1 to 2, and you can see both open. So this is not a point, this is an interval. Okay? So that's the interval going from negative 1 to 2. Oh, and the graphical one, so we draw the same thing, but we're going to color it. So we have that, but you can see it's going from so open at negative 1 and open at 2, but your answer is everything in between. So it's negative 1 and 2. That is the graphical version of that. Okay, so let's go to the next problem. So the next problem is negative 6x squared plus 11x minus 5 greater than or equal 0. And you can see that this problem has a problem here. You see that you have a negative 6 there. I mean, there's nothing wrong with that, but you can make this problem a little bit easier if you multiply by negative 1 the whole equation, because then you have a positive leading coefficient. It's much easier to work with. So we do that. We're going to multiply by negative 1. When you multiply by negative 1, what's going to happen? This is going to be 6x squared. You can change the sign. So it is negative 11x, a positive 5x, and it's also switch the inequality. So that's one of the very important thing. If you multiply or divide by a negative number, if you multiply or divide by a negative number, it's going to switch the inequality. Switch inequality. Okay, good. Now this is like a simple basic problem. So what you're going to do is we're going to factor. So if you can easily, I mean, if you can find write the factors, fine. But if you don't know, then we just use a regular technique. What we normally use the grouping technique to find the factors. So so let's do that quickly. So what's going to happen here is you can see the two numbers that you're going to multiply is 6 and 5. So you multiply 6 and 5, which is 30. Now you're trying to do is you try to find factors of 30 which added up to a negative 11. So what are the two factors of 30 which added up to negative 11? And you can see those factors are negative 6 and negative 5. Because it's gonna give you 30 and it's also added up to negative 11. So we can use those two numbers. Now let's do how the rest of the problem works. So we can write 6x squared and we can replace negative 11 by those two. So 6x, negative 5x, and plus 5 less than or equal 0. Now we can use the grouping for those two. That means 6x. You get x minus 1. Now you try to get x minus 1. That's the whole point. To get x minus 1, you see that you have to factor negative 5. So you get x minus 1. So, and then you see that these two match, x minus and x minus 1. Now you write 6x minus 5 first, and then x minus 1. Good. So we go for the zeros. So the zeros are, you can see x equal. So from the first one, you're going to get x equal 5 over 6. That's very easy to find because you set it equal to 0. Uh, yeah, so this is going to give you x equal 5 over 6. This one says x equal 1 because you are looking for 0. That means at what value of x is going to make that 0. You can see that you simply set each factor equal to 0. That's what you do. And you're going to get that number, and then the other one is 1. So those are two zeros. What we do, we're going to draw them on a number line, smaller to larger. So that means 5 half and then 1, and then we know by theory and we from the discussion that we talk about, uh, from larger to larger is positive, smaller to smaller it is positive, and it's negative inside. And you can also check that using a test point. And then what we are looking for is, we are looking for when this product is negative. That means we can look for negative or 0. That means you can see it's everywhere in between this. So that is the one, and it's including. So that means you can have the solution. So the solution is from 5 half and 5 6, because you can see the point endpoint is included because there's an equal sign. The equal sign means the endpoint is included. So it is 5 half 5 sixth to 1 including, and or if you use the graphical version, it's very easy now. So we just repeat this. So it is a solid dot, and everything in between we make it solid, and the two numbers are 5 6 and 1. So that is the graphical version. So this is how you solve a problem like that. So what do you do at the beginning? Since you see the negative coefficient, you multiply by -1 to make it positive. So it's easy now. And then we just do the factors. After you get the factors, you find the zeros and then mark them. And then you can use the test points to figure out is plus minus plus. And then we figure out where you need is the negative part. Okay, so let's go to the next one. So as the next problem, we have x squared plus x less than 2x plus 6. So what we do, it may look complicated, but what we're gonna do, we're gonna bring all the terms to one side. That's what we do. If you have terms on both sides, try to bring terms to one side. And then how we do that, we're gonna subtract 2x and we're gonna subtract 6 from both sides. So if you do that, you get x squared. If you subtract 2x from both sides, you're going to get negative x and negative 6. So that's what you get once you bring terms to one side. And then we're going to factor. So this is like very simple after that. So we're going to factor. So we have a negative 6, two numbers. So when you multiply negative 6, add negative 1, which is negative 3 and 2. So that means the factors are x negative 3 and x plus 2 negative. Now we're gonna go for zeros, and you can see this gonna give you x equal 3. This one gonna give you x equal negative 2. Those are the zeros, and we draw the number line. Put them in the smaller to larger. So it is negative 2 goes there, 3 goes there, and then we know that positive, negative, positive. So what we need is the negative side. So that means this is the one we are looking for, and you can see the corners are not included because there's no equal sign. So you can see the solution. So the solution is going from negative 2 to 3 open because there's no equal sign. Oh, and then you can write the graphical notation. So you draw the line and then put the two values, negative 2. Actually, we open that. So we have negative 2 and 3 open, and so that is the solution set. So which is negative 2 and 3. Good. So that's how we do it. Okay, so let's go to F, the next one. So what it says 3x squared plus 4x. It may look different, but it's the same type of argument. We try to factor this. So what are the factors? And you can see x is a factor. Once you take x out, you see 3x plus 4. So you can exaggerate 0. So you can rewrite it if you want x minus 0 and then 3x plus 4 less than or equal 0. And the zeros are, so this is that x equals 0. This one says x equal, how to solve? Bring 4 to the other side, so negative 4 divided by 3, so negative 4/3. So those are the two numbers. And then we're going to mark them on the number line. So we have 0 and negative 4/3, and the same argument, plus minus plus. So we are looking for where it is negative, so that means it's in between, so this region. So that means the solution set, which is an interval, so which is negative 4 comma 0, and you can see there's an equal sign, that means it's included. Okay, and you can use the graphical notation. We simply repeat this. So we have a solid dot there because the equal sign, solid dot there at 0, and then in between, so everything in between. So it is negative 4/3 and 0. Good. Go to the last problem, and again it's just the factoring is different. So we have x squared minus 7. How to factor this? We may recall something. Remember, if we have x squared minus y squared, this is going to factor into x minus y and x plus y. This is what we call the difference of squares. Difference of squares. Difference of squares formula. Okay, difference of squares. So we can use that fact here. So that means what we can do, we can write 7 as square root 7 squared. So we can write this one as t squared minus square root 7 whole thing squared. So we write like that. Now you can see, because the difference of argument, difference of squares argument, this is going to be t minus square root 7 and t plus square root 7. So it's the same thing again. This is that t equal square root 7. This is t equal negative square root 7. So those are the two zeros you're going to get. And then we're going to put them on the number line. The negative square root 7, positive square root 7. And by the argument, we know that's negative, positive, positive, negative, positive. So we are looking for is negative, that means in between the two numbers, that means here, and including the corners because the equal sign. So the solution set is going from equal to negative square root 7 comma to positive square root 7. That's the solution set, which is an interval, closed interval. And the number line, again we're gonna put two numbers, solid, and then this is negative square root 7, this is positive square 7, everything in between. Okay, so that's the solution. Okay, that's how we solve our basic quadratic inequalities. So let's go to the next problem. So this problem is slightly different. So what it says that, and you can see this is an inequality problem, but this is just the wording is different. So this problem has a different wording. So what it says that if hx equal x squared plus 2x minus 8, solve hx negative. So you can see if you convert it and then also use the solution using interval notation. So you see this is simply if you replace hx by the given function, this is simply asking solve x squared plus 2x minus 8 negative. So that's the problem, but this is very similar problem that we did a lot of similar problems in the previous problem. So what we're going to do, factor. Um, so you're going to think of two numbers of two factors of -8. Multiply, you get -8, and add, you get 2. That is 4 and -2. Those are the two numbers. And that means factoring is simply x plus 4 and x minus 2, negative. And again, the zeros are x equal -4 and x equal 2. Those are the two zeros you get. Draw the number line and put them in the order. So -4 and 2. We know that this is positive, negative, positive. For that, the leading coefficient has to be positive. If not, you cannot do this. So that means we are looking for negative. So that means the region in between. So so that means so you can say uh, the function hx is negative on, you can see it's in between, on -4 to 2 without the corners because there's no equal sign. So that's the answer. It's a very simple problem. Okay, so next, let's go to the next problem. So the next one is about solving inequalities. So let's talk about some of the theories that we have. So there are three types of problems that we have. So the first type of problem is with the equal sign. For example, let's say you have absolute value of x equal a constant. We assume a is positive. So if this is the case, there are only two possibilities. X has to be either a, or x has to be negative. So it's a plus or minus a. That's what happened when absolute x equal a, because it says that if you disregard the sign, it is a. Only possibilities are plus or minus a. That's the first case. That's like with the equal sign. The second one is absolute x less than a, or less than or equal a. So it means that if you have the equal sign, you put the equal sign. If you don't have the equal sign, you remove the equal sign. That's it. So what this says that the absolute value means the distance from the origin to the x value. It says that the distance, absolute x means the distance. So this is the distance from the origin. Distance from 0, from the origin. So it says that the distance is less than a. If the distance is less than a, it clearly says that x has to be in between the two numbers a and the negative a. Because if we draw the number line, it's very clear. So this is a number line, this is O, this is 0. So this is the a, and this is negative a. So if the distance has to be less, if the distance from the origin has to be less than a, the numbers has to be in between those two values. It's very clear with the distance. So that's why it has to be in between. The third case is the other way. So it is x greater than or equal a. So if that is the case, that means it's outside of this, because that's the inside. The number 2 is outside. So it's outside means what other things can happen? Either x has to be smaller. X has to be smaller. So that means so what we are looking at in this case is, let's graph it. So these are the a and negative a as before. So it says the distance from the origin is bigger. So that means it either has to be on this side or has to be on that side. Okay, so geometry is very easy to understand. So that means there are two different types of solutions. One solution is x has to be less than or equal negative a, right? So negative, less than or equal negative, or that's a o. X has to be greater than or equal a. So that's where the positive and negative come. It has to be on the left side or on the right side. That's what happened when absolute x greater than or equal a. And that's it. Those are the only theories we're going to use to solve absolute value equations or absolute value inequalities. So let's solve one absolute value equality problem just to make it clear. So I'm going to do like a star problem. So let's say solve this problem. Let's say 2 minus 3x minus 1 equal 5, something like that. Just put some numbers there. So this is an equal. It's not an inequality, it's an equal. That means the case number 1. So what we try to do, we try to isolate the absolute value term. So to isolate the absolute term, what we can do, we can add 1 to both sides. So we can write this one as 2 minus 3x. If you add 1 to both sides, it is 5 plus 1, which is 6. So you can see this is exactly like the case number 1. So you have an absolute function which is equals to a positive term. So if this is the case, then theory says that there are two cases to consider. So what are the two cases? Either whatever inside has to be equal to 6. That's the first case. So that means 2 minus 3x equals 6. Or 2 minus 3x has to be negative 6. Those are the only two cases that can happen. Because you see that when you take the absolute value, you see absolute value exactly equal to 6. Those are two cases. Now what we can do, we can solve them separately. So the first one, which it's very easy to solve. So you're going to subtract 2 from both sides. So it is negative 3x. You subtract 2 from both sides, it's going to be 4. And then divide by negative 3. So if you divide by negative 3, it's going to be negative 4/3. So that is the first solution. And the other one, again, we subtract 2 from both sides. It's going to be negative 8 if you subtract 2. And again, divide by negative 3. So x equal negative 8 over negative 3. So you can see which is 8/3. So those two are the two solutions. So that means the solution set, the solution set is, because a set, so you have to write as a set. So it is negative 4/3 and 8/3. So those two are the two solutions. That's not part of the problem, but I want to show you like how it works. So that's very easy. You just so the major part is this one. You're gonna get two different solutions here. Because there's one for 6, there's one for negative 6. It can be any of them. Okay, good. So let's try to solve those 4 problems now. So the first problem says absolute value of x plus 4 less than or equal 3. You can see this is of this form. So what we have is absolute value of x less than or equal to a form. That means we know the solution of this one, how it looks like. So that means because of that, we can say this directly implies that x plus 4 has to be between 3 and negative 3. That's what it means. And then, so that directly comes from the argument that we discussed. So, and then what we can do, we can subtract 4 from both sides. If you subtract 4 from both sides, it's a negative 3, negative 4, less than or equal x, and then 3 minus 4. This is unnecessary, but you can write it. So you get negative 7 less than or equal x less than or equal negative 1. So that's a solution set. That's a solution, but we can write this using interval notation and the graphical notation. So it says that so the solution set. So the solution set is going from negative 7 to negative 1, including the corners. Or if you use the graphical one, you can see you're going to put the two numbers, which is negative 7 and negative 1, including, so we use the close bracket version. So this is negative 7 and negative 1. Or you can use the dot version. Okay, so that's the first type. So the second type, so you can see this problem is almost like x greater than or equal some number. So, but from the theory, we know that it has to be outside. So that means, so what this says that, x minus 5, whatever inside, okay, whatever inside, x minus 5 has to be less than or equal negative 3, or it has to be on the right side. That's the left side, or on the right side. Right side means x minus 5 has to be greater than or equal 3. So this part is coming from theory. Okay? This part is coming from theory, and this is what coming from theory. Okay, now we're going to solve those two separately. So we're going to add 5 to both sides. If you add 5 to both sides, you can see this is so negative 3 plus 5, that means 2. And then oh, so we have, you add 5, so you're going to get x greater than or equal. If you add 5, which is 8. So it says less than 2 or greater than 8. So if you can write the solution set, so the solution set is, how to write it? So you can see it will be x less than 2 is going to be negative infinity, comma 2 including 2, and then with the union, because that's the only way you can combine them. You can see it's greater than 8, so 8 to infinity. So that's the internal notation. So the graphical notation is we draw the number line, and then so you can see, so this is 2, the smaller number, and then on this side we're gonna do that. So that's 2, and then from 2 to infinity, that's on that side. So this is 8. So those two are the two numbers. That's the graphical notation for that. Okay, so let's look at the next problem. So so what's the next problem? Is about 2k minus 5 plus 4 less than negative less than 11. So if you get a problem like that, what we're trying to do, so you can see this is, you have to bring it to x less than a or x greater than a form, to one of them, depending on the coefficients. So, but you can see that means you have to isolate these terms. That's how we're trying to do it. You're going to isolate the term. To isolate that, you're going to subtract 4 from both sides. So that's the starting point. So you can see, so we have 2k minus 5 absolute value plus 4 less than 11. So what we're going to, we're going to subtract 4 from both sides. So when you subtract 4 from both sides, you get 2k minus 5 absolute value less than, if you subtract, so it is 11 minus 4, which is 7. Now you can see this is of this form, 2k minus 5 less than 7. So you can see that is in this form now. That means we can use the theory right now. So we can, that means this number has to be between negative 7 and positive 7. So that means this directly implies that, uh, negative 7 less than 2k, negative 5 less than 7. Okay, so it's in between those two numbers. Now what we can do, we can add 5 to both sides. If you add 5 to both sides, you can get negative 2 less than 2k less than at 5, so you get 12. And then what we do, we divide by 2. If you divide by 2, you get negative 1 less than k less than 6. So that's the solution. So the solution set is, you're going to have negative 1 comma 6. That's the solution set. Or if you use the graphical notation, you can see it is in between negative 1 and 6. I time to time use the both versions just to make you comfortable. So it's up to you what version you're going to use. You can use this version or the circle version. Okay, so that's the answer for that. So so let's go to the last problem of last part of this problem. So what it says that 2 times 3 minus 2k negative 1 greater than or equal 5. Again, you have to bring it to one of those forms. You have to bring it to either this form or that form. So let's see what's going to happen. So we have, so we can isolate the absolute term first. We can isolate that. That means you're going to add 1 to both sides. So I'm going to repeat the question first. 3 minus 2t minus 1 greater than or equal 5. You add 1 to both sides. So is it 2, 3 minus 2t. If you add 1, you're going to be 5 plus 1, which is 6. Now what we're going to do, we're going to divide both sides by 2. So if you divide both sides by 2, you're going to get 3, because we don't need this term, so we can divide by that. So it's 3 minus 2t greater than or equals 6 over 2, which is 3. Now you can see we have 3 minus 2t greater than or equal a number, greater than or equal a number, and that is the form we are looking for. Then we can directly use the theory. So it is of this type. So from the theory, this says that 3 minus 2t has to be less than or equal negative 3, or 3 minus 2t has to be greater than or equal 3. Now we try to isolate this term, the t. That means you subtract 3 first. So if you subtract 3, you're going to get negative 2t. If you subtract 3, it's going to be negative 6. And then divide both sides by negative 2, which is a negative number. So they're going to switch the sign. So that means it's going to be greater than or equal. And negative 6 over negative 2, which is 3. So it says that t greater than or equal 3 is one solution. The other side, you can have subtract 3, so which is negative 2 greater than or equal 0. Again, we divide by negative 2, which is a negative number. So that means it's going to switch the sign. 0 over negative 2 is still 0. So it says t less than or equal 0. Good. So that means that's going to give you the solution. So the solution set is so it says t greater than 3 or t less than 0. So that means you have negative infinity to 0 and including 0, or it says that 3 to infinity. So that's what you get. So if you graph it, so you're gonna have so let's use the circle version. That's a solid circle, 0, and this is not t, this is 3 greater than 3. Okay, so we have 3 here. So it says that 3 or less than 0, including 0 and 3. Good. That's a graphical version. Okay, that's how we solve the inequality. And yeah, so let's go to the next problem. So in this problem, what we're trying to do, we try to find the maximum or minimum value of a function. But this is not just a general function. This is a quadratic function. So when you have a quadratic function, you can see that the quadratic function always have a vertex, either maximum or minimum, depending on the coefficient of the x squared term. So, these kind of problems are what we normally call the maximum minimum problems, or what we call optimization problems. So you try to find the optimum value of the function. So when it is a quadratic function, there's like a shortcut. So what's going to happen? We know that when a is positive, so you have a graph like that. That means there's a minimum. And then when a is negative, the graph has a shape like that. That means there's a maximum. So, so you can see this is a minimum and there's a maximum. And you can see the minimum or maximum always happen at the vertex. That means the HK. So what the theory says that the vertex, which is we normally write as HK, that's how we normally use. And you can see that that happens at the h is always given by negative b over 2a. That's the h value. The k value is you simply plug in the same value back to the function. So it is f of negative b over 2a. That's what the theory says. So that means we simply calculate. So if you need the maximum value, so this is going to be the maximum or minimum value always. So this is either maximum or minimum depending on a. So that means we simply need to calculate the f of negative b over 2a is going to be the maximum or minimum we are looking for. So that's exactly what we're trying to do. That's what the theory says. That means this problem is a really simple problem. What we need is what is a and what is b, and we can plug in. So let's see how we can do this problem. So if you go to the first problem, so which is fx equal, we have x squared plus 4x plus 5, and you can see ABC is in the right order. So which is here a equal 1 and b equal a equal 1 and b equal 4 and c equal 5. We don't need c for this problem. So but also we see that a equal 1, which is greater than 0, that means it's concave up. So it's concave up. Concave up means has a minimum. So it has a minimum. So that's what the theory says. This has a minimum. What is the minimum value? F of negative b over 2a. So that means the minimum is, so the minimum is, it is simply f of negative b over 2a. So we're going to find this. So it is f of negative, what is b? So you can see this b is 4 over 2 times a is 1. So that means if you simplify, you're going to get f of, simplifies, you're going to get negative 2. So that means it is just f of negative 2. That means go to the function and plug in negative 2. So it is negative 2 squared plus 4 times negative 2 plus 5. So that if you simplify, you get 4 and negative 8 plus 5. So that means you're going to get 1. So that means 1 is the maximum that function can attain. Okay, so actually it's not the maximum, the minimum that can attain. So that is the minimum value we are looking for. Okay, it's a very simple problem, and let's try to do the other problem like that, but numbers may not be difficult to work with, but that's okay. But theory is like that. So let's do the next problem. So we have this function, but what do you notice? You can see that those terms are not in the right order. B is over there, so you have to be careful. So what we normally do is we can rewrite them in the right order. So it is negative 2/3 t squared plus 4t minus 1. So so that is the function, and then we can identify ABC. So is A is negative 2/3, and then B is 4, and C is negative 1. And again we notice that A is negative 2/3, which is a negative number. That means has a maximum, So what we can do, the maximum is, so the uh, maximum is f of negative b over 2a. Again we just gonna plug in, so it is f of, let's plug in, it's a negative, b means 4 over 2, a means negative 2/3. So you have to be careful with these numbers, uh, and how to simplify this. So you can see we have 2 and 2, which is 4, and that cancels with this 4. That means all those terms are gone, and then negative negative, so we have two negative signs, they also cancel each other. So you simply get f of 1/3. So you get what do you get? So you can see it is f of 1 over 1/3. That's what you get. That means f3. So this means that f of 3. So that's what you get. So that means you're going to go back to the function, plug in that value. So another way is you try to simplify this first, and then so simplify this first. That's like another way, and then we're gonna plug in that value. So, but this says that it's f3, so that means go to the function, plug in 3, so it's negative 2/3, and we have 3 squared plus 4 times 3 minus 1. So you can see 1 3 get cancelled, you get negative 6 plus 12 minus 1, so which is 5. So that means the maximum is 5. The maximum of f is 5. Okay, so that's the value it can attain as a function. And also you can do a problem like that using completing square method also, because once you do the completing square, you go for the k value, and that's the maximum. Okay, so use completing square. That's another method. Use completing square and identify the k value. Okay, identify the k. So that's the value you get. So okay, that's how you solve a problem like that. So let's go to the next problem. So it says that to find the equation of the parabola, if it has the vertex is given and also one point is given. So if you know the vertex and a point, so let's just draw like some random uh, parabola. So it's like that. So it says that it says vertex is given. That means HK is given. HK is given, and also one point is given. So it says that at 1, so it's going to pass through 1, -7. So since the vertex is given, so what you can do is you can write the standard form. So the standard form is we know that it is fx, so which is a x minus h squared plus k. But vertex is given, so since the vertex is given, we know that h equal -2 and k equal 5. So we're going to plug in those two values here. So that means so then the fx function is simply, you can write as a that we don't know. So so we have x and then minus 2, that's the h value, squared plus k is 5. So this can simplify to a x plus 2 squared plus 5. So that's what you get. Now what we're going to do, since we know that it passes through, since it passes through 1, -7, this point should satisfy the equation. That means it's -7 equals a times x equal 1. So it's 1 plus 2 squared plus 5. Now what we're trying to do, we solve for a. So we can solve for a. So I'm trying to do, that's not that difficult. We can move 5 to the other side. So you're going to get -12 equal a times, this is 3 squared. So 3 squared, that means 9a. So this says that a equals -12 over 9. So 1, 3 get cancelled, you get 4/3. So that is the a value. So once you know the a value, and you can see y equal, a is -4/3, and we have x plus 2 squared plus 5. So this is perfectly fine, but if you want, you can simplify this further and write it like that. So you can say 1/3, and if you use the if you distribute this, you're gonna get x squared plus 4x plus 4. That's what you get, and then plus 5. Now what we can do is we can simplify this. So if you simplify, you're gonna get -4/3 x squared. You don't have to, but you can simplify. And you're gonna get -16 over 3x, and then you have -16 over 3 plus 5. So this after you simplify and multiply by 3, after you simplify and multiply by 3, you can write this one as I can say y equal -4/3 x squared minus 16 over 3x 1/3. And what you can do is you can also multiply by 3 to write in another form, but this is the parabola you are talking about. So what we did was we used the standard form and plug in the vertex which is -2, 5. Okay, so let's go to the next problem. In the next problem, what is asking, find the real zeros of the function. So it is just like a basic like how we kind of apply these techniques to find the zeros. So what we normally do is we can use the factoring method, special factoring methods, or maybe sometimes even can use some kind of substitutions to solve problems. So let's look at one by one. So let's do the first problem. So as the first one, we have fx equal 5x squared minus 28x minus 12. since we are looking for zeros, what we're going to do, we're going to set this equal to 0, set this equal to 0, and then solve for x. How we do it, we're going to use a factoring method for this one. So we are looking for, what are the number we are looking for? It is 5 times negative 12, that means negative 60. So we are looking for two numbers. When you multiply, you get negative 60, and when you add, you get negative 28. And you can see those two numbers are negative 30 and 2. So once you know those two numbers, so what we can do, we can say 5x squared minus 30x plus 2x minus 12 equals 0, and we're going to group them. So you're going to get 5x as a factor, which is x minus 6, plus 2 as a factor, x minus 6. So you're going to get 5x plus 2, x minus 6 equals 0. That means if you set the first one, so you're going to first one equal to 0 or the other one equal to 0. So this says that x equal, if you bring to the other side, is 2 divided by 5, or x equal 6. So those two are the two answers of the first one. So let's go to the next one. So as the next example, we have gx equal x cubed minus 9x. So what we're going to do, we're going to use a simple, like a similar method as we use for quadratic equations. So what we're going to do, we just use a factoring. So we try to see whether we can factor. So that's what we do. So factor. So we start with gx. So since we are looking for zeros, we're going to do x cubed minus 9x. We set it equal to 0. And then we use a factor. And we can see that x is a common factor. Once you take x out, you're going to get x squared minus 9 equals 0. This is very easy to find factors because you can write 9 as 3 squared. So this is x, which is x squared minus 3 squared. And then we can use the difference of squares. So it's x minus 3, x plus 3 using the difference of squares argument. If you do not remember, it is x squared minus y squared is equals to x minus y and x plus y. So that is the difference of squares argument. Now since you have three factors, you can set each factor equal to 0. You can make an exaggeration. So I mean, you can say x equals 0, that's one factor, or x equal negative 3 equals 0, or x plus 3 equals 0. Why we write 3 or 2 O's there? The reason is when you have a product equal to 0, if one of them can be 0, we don't need everything. So that's why we set them equal to 0 one by one. So that means the solutions are x equals 0 or x equal 3 or x equal negative 3. So the solution set is plus or minus 3 and 0. So those are the solutions you're gonna get for that. So as you can see that it's just extension of the quadratic like factoring method. You can just factor them. So let's look at another very interesting example also. So let's say you have some problems like that. It doesn't look like quadratic. So what we can do, if you see something like that, for the least term, we can use substitution. Okay, so we can use a substitution technique for the least term. So why is that? And you can see that if you say u equal square root x, then you can see that u squared equals square root x squared, which is x. So that means then you can rewrite. Okay, so we're gonna rewrite the equation as, okay, rewrite the equation as, so you can see x is simply u squared. Now it's u squared minus square root means u minus 12. So we set it equal to 0. You can see this is a simple quadratic equation, and we can solve this for u. Okay, so we say solve for u. Once you solve for u, you're going to go back, and then we're going to use u equals square root x to find x. So that's a two-step method. So let's try to do that. And then you can see this is like easy to factor. So this is x u minus 2 and u plus 1. Those are the factors. So this says that u minus 2 equal 0, or u plus 1 equal to 0. But you can see this is impossible. The reason is u is square root x, and which is greater than or equal to 0. That means there's no way u plus 1 can be equal to 0. That means there's only one solution. So u minus, so you can say since, okay, so then you have this solution. So u means square root x, so this says that square root x equal to 2. So in other words, if you square, you can see that x equal 2 squared, which is 4. And you can clearly see that once you plug in that value, it actually satisfies the equation. So we check. Okay, so we're gonna check the value and see that because when you square, it can introduce extra solutions. So you always need to check. Okay, always. When you square, you always have to check whether that's a solution, because it can introduce extra solutions which are not the solution of the original equation. So you can, when you check, and you can see that it's gonna satisfy, so that means x equal 4 is a solution. Okay, so x equal 4. After checking, you can see x4 is the solution. Okay, so that's how we use a substitution technique to solve some equation that doesn't look like quadratic. Oh, so this is like a very common trick we use. Okay, so let's go to the next problem. So next problem is about graphing a piecewise function. So this is one of the key knowledge student need to have, how to graph piecewise function, because these are very, very common in many of the other STEM areas and even in non-STEM areas. So, and also ask you to find the domain and the range. So we're gonna graph this piece by piece. So one of the complicated function would be this one. So we're gonna look at that one first. So how to graph that? So you can see so this we can say y equal, we can start with y equal x squared, and then we're gonna go to y equal x minus 3 squared. That's gonna shift the graph 3 units to the right, and then we have y equal x minus 3 squared minus 1. This is gonna bring the graph down by 1. So if you go step by step, so what happened, so in the first one you have y equal x squared, so that is that graph, and then it's gonna, you're gonna shift that to the right by 3 units, so that means it's gonna go like that. So this is 3, this is 0, and then finally we're gonna bring this down by 1. So if you bring down by 1, you're gonna get a graph like that. So 3 stays the same, so the graph gonna go down by 1. So it's gonna go down like that, go like that. So that is the graph, and so this is -1, and then you can see so if you plug in so what is this value? So there are several interesting values you need. So this is one value, and you can see the question is when is going to be 0. So for example, you're going to solve this one. So you can see x minus 3 squared minus 1 is set it equal to 0, and when you solve it, you can see x minus 3 has to be plus or minus 1. That means x is simply 3 plus or minus 1. So that means it is 2 or 4. So the two values are either 2 or 4. Those are the two values. So that means now we can actually graph the piecewise function. So so we have a few pieces to fuse together. So this x-axis and the y-axis, and you can see so some values we need is, the first one is y equal 3 plus x or x plus 3. So that means the y-intercept is 3. but it's gonna get values up to 2. So so we have 1, 2, 3, 4, and then it says that it's gonna go up to 2. So that's the 2 um, and the 4. So at 2, you can see that you're gonna get 5. So so it's gonna go up to that number. So it passes through like that. So that is the 3. It's gonna go this way, and 6. Okay, so that's so this is, it's not in the right axis, so that's 5. That's 5. Good. That's about that part. And then it says that at 2, which is 2, so it is 2 is 3, so it's 2 at 2. And then for more than 2, we're gonna pick the graph we draw. So you can see 2 is not included. That means there's an open dot here, and it's gonna go down to -1. It's gonna go up. So that is the graph we're gonna get, and that value is -1 right here. So that is the graph we're gonna get for the piecewise function. Okay, so so let's do the final problem. So what we have is find the equation of the parabola. Find the equation of the parabola that passes through 3 points. So this is like one of the major theory in mathematics. So that means, for example, if you know any 3 points which are not on a line. So if I get any 3 points, like let's say we have 1 point there, 1 point there, and another point there. So if you have any 3 points, the theory says that there is a unique parabola that passes through those 3 points. If they are not on a line, there's a unique parabola that passes through these 3 points. For example, we can connect these using this parabola. It's going to go there and it's going to pass through like that. So that's the parabola we are talking about. So that means there's a unique parabola that's going to pass through these 3 points. So that happens for any 3 points. So that's the kind of problem we are trying to do. So what we can do, we can assume like a standard form, and we're going to plug in. So we're going to say, so let fx equals ax squared plus bx plus c, because that's the general form of parabola. Now what we can do, we can apply in those points. So because we know that each point passes through, the parabola passes through each point, each of those points gonna satisfy this equation. So since, you can say, since negative to 10 is on the parabola, so we can see we're gonna plug in. So that means 10, not negative 10, 10. So we can write 10 equal. So we're gonna plug in the value -2 into the function. So a times -2 squared plus b times -2 plus c. So this you can write as 10 equals 4a -2b plus c. And similarly, 1 -2 gonna implies that you're gonna get -2 equal, we have a plus b plus c, and then the point 2, -2 says that we have -2 equals 4 times, so we have 4a, and we have 2b, and then plus c. Now what we're gonna do, so we have these 3 equations, and we're gonna solve these 3 simultaneous equations. Okay, by solving these equations, we have, so we can solve those for those 3 equations for a, b, c. So we have a equal 1, and b equal -3, and c equals 0. So that means the parabola you are looking for is a is 1, so that means x squared minus 3x. And you can see that this is going to pass through those 3 points. That's how you solve a problem like that. Okay, so this is the part 2 of the review.